Welcome to some binomial expansion. This is officially your last flipped classroom video if you choose to not have flipped classroom anymore, which is actually one of your tests that you have to take. But if this is the last flipped classroom video, then it's been great doing this. So here you go. So here's what's called Pascal's triangle. Pascal's triangle is used for a lot of different purposes, and there's lots of different patterns. But we're going to be able to use this for binomial expansion. So your top row is going to be to the 0 power. This is going to be to the first power. And then if we had something like x plus y to the second power, these are all x plus y's. That's to the first power, to the 0 power. This would be x plus y to the third power, x plus y to the fourth power, x plus y to the fifth power. The second number will tell you what power it is. So this is 1, so that's why there's a 1 here. 2, 2, 3, 3, 4, 4. This is the fifth power. The triangle continues on forever. For this triangle, you start at 1, and then both of these columns here are 1s. And then to get to this one, you're just going to add these two numbers. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. And then to get this row, we would do 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then the 1 is always on the end. So that's Pascal's triangle. There's lots of different patterns within this, but we're going to be able to use this for binomial expansion. Okay, so we're going to keep that up here. You might want to write this down so when you do some of these problems you can, but since I have the capability, I'm just going to go ahead and leave this where I can see both of these at the same time. So we want the second term in the expansion. When we expand this, so we want the fourth one, so that would be this column. We would want 1, 4, 6, 4, 1. So we want those numbers, and then we want to be able to expand it. So basically we're going to have x and y in all 5 of these sets. So this is going to be x times y, but in the first set you're going to have the x to the fourth power and then y to the 0 power. And then you're going to count down from your x's, and then you're going to count up for your y's. So here we're going to count down from our x's, so then we have a 4 here in the front is our coefficient. We have x. It was a 4, now it becomes a 3. And then y now becomes a 1. And then we have our next coefficient, which is our 6. Our x goes from 3 and it goes down to 2, and then our y goes up from 1 to 2. So our y's, the second value, is actually going up, goes 0, 1, 2, all the way until you get to 4, and then the x's go from 4 to 3 to 2, and it's going to go down to 0. So our next coefficient is 4, and then x becomes to the third power, or I'm sorry, x goes to the first power, and then y goes to the third power. And then we have the 1 with x to the 0 power and y to the fourth. Now, we know our rules with anything to the 0 power is just 1, so this really just cancels both of those. So this is really x to the fourth plus 4x to the third y plus 6x squared y squared plus 4xy cubed plus y to the fourth. So if we were to expand this and actually multiply this out, like we would do x plus y times x plus y, and you do that 4 times, and you FOIL it all out. This is what you would get. So this is a kind of a cheating way or an expansion that you can do to solve it. Now the question says, what is your second term? So this is your first term, this is your second term. So our second term is 4x to the third y. So this would be our answer. Okay, so then we're going to go ahead and do this one over here. So this, now we want the third term. Let me see if I can fold this over so you can see both of these at the same time. Okay, so we want the third term in the expansion. I know this says to the fourth power, but let's go ahead and make this to the fifth power just so we can see a different row here. So what we're going to do our coefficient of 1. And then we're going to do both of these values. So we have x to the fifth power, and then we have 2 to the 0 power. Even though it's not a variable, it's a constant, we can still do this. So the 2's are increasing and the x's are decreasing. So then our next one is 5. our x goes down to 4, and then our 2 goes to the 1. And then we have 10 as our next coefficient, and then our x goes down, and our 2 goes up. And then we have 10 again, our x goes down, and then our 2 goes up to the third, and then plus, and then we can keep going on, but we only want the third term, so that's this right here. So we need to be able to expand that out. So that's 10. We have x cubed. 2 squared is 4, so that's just 10 times 4, so that's 40 x cubed. So we can keep expanding this, but the question asks for the third term, so you don't technically need to go all out. But if it is like an end of course question, you're going to be able to need to know how to do all of those, or a question that we're going to do tomorrow in class. Okay, now at the very bottom, we just want to know what the coefficient of the term described. So if this is the fourth, so that means we're going to be in this row with the 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. Those are our coefficients. And we want to know what it is with x and then y to the third. Well, we can just start writing out what the coefficient, or what the pattern would be. So we would have x to the fourth, y to the 0. And then we would have x to the third, y, and then we would have x squared, y squared, and then x, y cubed, and then x to the 0, y to the fourth. So these would be our numbers, so there'd be a 1 here, a 4 here, 6, 4, and then the 1. We want the one with the x and the y cubed, which is this one. So then now we're going to plug in our values. So we had 4x. Our y is negative 3y, and we're cubing that. So we're plugging it in. So the negative 3 cubed is negative 27, and that's times 4. And then we have x with a y cubed. Sorry, that's a y cubed. So that's going to be negative 108 xy cubed, but it asks for the coefficient. So all we really care about is that number. So then the answer is negative 108. Okay, so for this one, we just had to multiply it all out. Now, here's the last one. These don't have any numeric values. It's just the m and the n, just like an x and a y. So we have the 1, 4, 6, 4, and 1. So all we really need to know is which coefficient, 1, 4, or 6, that we're going to use, but we need to find the m squared, n squared. So we're going to start with m to the fourth, n to the 0, and then we have m to the third, n to the first. And then we have m squared, n squared. That's the one that we want. So that's the third one, which is 6. So our coefficient is 6. Okay. This is pretty basic, but there's going to be like 1 or 2 on your end, of course, maybe. You never know. So that is how to do binomial expansion. Thanks.